Hello and welcome to another episode of the Geotechnical Engineering Podcast. Today we'll be talking with Gohe Metaferia, who has a Master of Science and also a professional engineering license. He's the Geotechnical Practice Director at Atkins Realis. We'll be talking about his experience leading geotechnical teams on complex projects throughout Canada. We'll also be talking about the importance of technology and how it relates to innovation within geotechnical engineering. And we'll also be talking about what goes into incorporating international design standards into geotechnical engineering projects. I'm your host, Jared Green, and I'm excited to be bringing you another episode of the Geotechnical Engineering Podcast. But before we get started, we're going to hear a word from today's sponsor, that being PPI, a Kaplan company.
PPI provides expert prep courses and study resources designed to help you pass the FE and PE exams the first time. PPI's live online courses include hours of lectures, problem-solving demonstrations, exam strategy sessions, office hours, and a passing guarantee. Check out PPI today at ppi2pass.com to see all the options available for FE and PE exam prep. Now let's dive into today's episode.
Gohe, how are you doing? Welcome to the show.
Doing great, thanks, and it's a pleasure being here. I'm a long-time listener of your podcast, so it's an honor being here, actually.
Excellent. I was glad to know that we have long-time listeners. We're over 100 episodes, which is pretty wild to believe, but glad to be here with you. So thank you for that.
Definitely glad to be here.
All right, Kid, start out by telling us a little bit more about yourself and talk about your career journey. How you got to become the Geotechnical Engineering Practice Leader at Atkins Realis. That'll help us to kind of set the stage for the episode.
Yeah, definitely. Well, I guess you could say that the apple doesn't fall far from the tree. My dad himself is an engineer, a civil engineer at that. So I got first row exposure to the profession from a young age. I got to see my dad tackle some of the largest infrastructure projects and challenges in Ethiopia, because that's where I'm originally from. And he went on to establish and lead a successful business engineering consulting business. So I got to appreciate what it took to be an engineer from a young age. I'm naturally as well someone that loves and appreciates solving complex and head-scratching puzzles. Let's put it that way. So I'm naturally inclined towards the sciences and ultimately to engineering. So I came to Ottawa and to pursue my undergrad studies. I found this program that had a dual degree in civil engineering and IT, which was a perfect marriage for the two interests that I had. So once I finished my undergrad that summer, while I was waiting to start my grad school, I got offered a job for what was supposed to be a summer gig in a specialty deep foundation firm. I remember the first time I went out to site and I was witnessing the construction of a deep caisson that I had helped design. And that I remember looking up in the sky and seeing this 130-foot cage being lowered into the drill shaft. And I was just amazed, not just at the scale of the structure itself, but the logistics that it took to put that together and to make that happen. And sure enough, I went and followed and completed my my grad school. But that summer gig, what was supposed to be just a summer gig, ended up being a 7-year job. I stuck with it for a while, and fast forward, I joined SNC, which later became Atkins Realis. And at SNC or Atkins Realis, I met some great mentors and colleagues that gave me the opportunity to tackle some of the largest projects in the country, and also put my that skill to test and assume different roles. And here I am today, part of the Geotech Practice Leadership team, and I'm currently leading our practice in Central and Atlantic Canada.
Okay, excellent. Wow, that's fantastic. It's always interesting when you're in school and you're doing these homework assignments and you're designing things, and you don't really think about how you get it in the ground. And then when you go to the field and go to site, actually see what it takes to put it in the ground, it's pretty impressive.
So, telling you, man, it's like, you're right. Okay, 30 meters. Yeah, just numbers, right? You go out to site and it's the amount of people it takes, the amount of effort it takes, and the almost military-like precision it takes for everyone to come together, that was just love at first sight. And then I never left geotech from then on.
That's great. That's great. Well, what are some of the key qualities that you look for when you're assembling a successful geotechnical engineering team? What are some of the things that come into mind for you?
Well, like most teams, if you're seeking success and actually excellence, you would want to make sure diversity is part of that sauce that you're putting together. Diversity in experience, diversity in views and expertise. Obviously, I'm not saying have 10 of every expert, but have that combination of people that will challenge each other to push the boundaries. But more than that, specifically in geotech, I find our work is often questioned, if not challenged, especially in the framework of major projects. And we were having to often explain our contribution. So what I often look when I'm putting together a team for a specific project is an actual advocate for the team. And that person could be someone that's on the team or an ally that's sitting on the sidelines, that understands what geotech is and understands the contribution of geotech, and that's able to articulate, the different findings, to articulate the challenges that the team is facing and what the client is trying to resolve, but also convince and help address the challenge by convincing the client and the different stakeholders of the solution that's been put forward. So I would say the key component to a successful team beyond all the technical expertise is that advocate, especially for geotech engineering.
Very important, very important. And how would you say that you foster a culture of innovation and collaboration within your team, especially on complex projects that involve deep foundations and slope stability?
Oh, definitely. That's an awesome question. So when we think about innovation, a lot of times our mind runs wild to, high tech and new inventions. And definitely innovation can come from that aspect as well. But in geotech specifically, it takes many forms, and sometimes it's not necessarily high tech. But as long as it's focused on overcoming the actual constraint of the project, that's when you start breaching the boundaries of your traditional geotech or traditional engineering solutions. And that's why a lot of times I focus and I try to challenge my teams to really think about what challenge they're trying to resolve. For example, a few years back, we were working on this infrastructure project where we had to put together a high embankment over highly consolidated compressible soils. And obviously, you can come up with a number of different foundation technologies to overcome that. But one of the key constraints was time. So whichever design solution you had to come up with had to overcome the time constraint. And that's how we were able to put together a combination of filled materials and a combination of ground improvement techniques and a sequence of construction that allowed to overcome that time-bound constraint. And as such, the overall solution was innovative. But if you were to ask me, what about it was fancy? Nothing, honestly. But the client really appreciated the fact that we took into consideration the actual constraint, and that's where you would qualify the solution as being innovative, because you're going beyond just the traditional solution for geotech problem.
Makes sense. And understanding what that key aspect is could be the difference between having a successful project and not, right?
Definitely.
If it's time and you're focusing in on, specific materials, it's like you could lose, right? So
yeah,
that's important. That's important. Now, what do you say? Can you describe a challenging project where your leadership really made a difference in the outcome? Does any project come to mind?
To be honest, yes. As a leader, there's been instances where I had to step in and help the team move forward. But I would shy away from saying that it's my leadership that helped. It's always a team effort. It's always an endeavor to bring about efforts from different stakeholders. I remember a while back, I was brought into this project where, practically speaking, the structure had failed, or was failing. Let's put it that way. And at the core of the issue was that there were too many stakeholders with very poorly defined roles and responsibilities, and a bit overlapping scopes, if you will. And obviously, the client was not happy to see the least that their project had stalled, and the contractors and designers and different consultants were weary and anxious to know that their work is being questioned and interrogated. So where I would say the leadership came into play is where it required someone to stop everyone and say, hey, let's realign and understand where we stand and understand actually what the challenge is and work towards a best for project solution. And after the whole shebang, at the end, the issue boiled down to, seriously, one term that was interpreted in 3 different ways from 3 different designers and contractors. And again, this goes back to that strong advocate for your team. It's not just having the voice to speak for the team and the work, but also understanding the ambiguity that surrounds geotech engineering and how that relates to different disciplines. And so leadership could very well be as simple as getting people together and working together.
Wow. That's really makes a lot of sense. And, sometimes we're moving so fast that we don't take time to do that. And in that case, that one term's described 3 ways that you could think of a lot of ways to solve that. And every one of those solutions comes back to the 3 parties coming together and saying, hey, what does this actually mean to you? Right?
Yeah. And I mean, without going into much detail, you can think that this is like a fancy term that is legally interpreted in 3 different ways. But no, not really. It's things like, spring and modulus and stiffness mean completely different things to different disciplines of engineering. And geotech is no exception. So when we're providing recommendations, we ought to understand how the audience will receive that. And same thing, settlement and deflection will mean something for geotech. It's completely different for the structural engineer or the mechanical engineer that's actually trying to make things move and deflect. So just understanding that ambiguity there is at the boundaries of our discipline. I think that's where we sometimes see the challenges and the focus shift.
Yeah, no, you're absolutely right. Absolutely right. But what are some of the strategies that you've employed to manage and oversee multiple projects across different regions like you've done throughout Canada?
So I find that geotech engineering, much like a few other disciplines, is one of those disciplines that actually generates a lot of measured data. And you can focus on, reaching out to your team members and saying, hey, did you get the right test results? Did you pass that on? And does it make sense? But I've noticed, and I guess this large volume of data that we generate and its flow creates this opportunity for creating checkpoints. Without having to really manage the people, you can manage the work and you can manage the progress of the work, create generate the data in the field, and you transfer that to your project manager or your senior engineer to review it, not having to go to all your team members and say, what does the data look like and how was the progress? You can simply look, hey, when was the data produced? How fast was it transferred? Are we still on schedule? And is it quality data? Same thing from analysis or to the lab when samples are generated and then ultimately tested in the lab. And from lab and field when it's aggregated into a model and it's put together for a final design, you can look at the flow of data instead of having to manage your people. And so I often let technology do the management for me. I try not to manage the people, but instead I try and focus on leverage leadership with my people. As what I find makes the difference is, keeping an ear open and eye out for what is my team missing to achieve the metrics that I've set for them for success. And instead of bugging them every 2 seconds on whether or not they've actually achieved that.
Makes a lot of sense. Nobody wants somebody looking over their shoulder, micromanaging them, right?
Definitely.
Let me do the work, right? Let me do the work. Let's see. So, keeping with that mindset of leadership, how has your involvement with the University of Ottawa's Civil Engineering Curriculum Advisory Board influenced your approach to leadership in geotechnical engineering?
Oh, great question. And to be honest, it's an area that I didn't really expect that I would be asked about, but I'm glad that you did, because when I first volunteered to get involved with that committee, I thought, why not? I'll contribute to my alma mater and I'll keep an ear out on how things are going. But it turns out actually it's it's a window into what academia is facing in terms of challenges and what kind of tools the next generation of engineers are receiving as education, and what kind of skills they're receiving, and what kind of expectations they have of the actual industry. So as a result, what I find myself doing is actually shaping my team and shaping the tools that we have at our disposal to welcome the next generation of engineers. And I happen to kind of glass over my wife's work every now and then, and she works in IT. And there's this terminology that she shared with me, and at first I thought she was joking, but there is such a thing called digital immigrants and digital natives. Well, what is this whole thing? And it turns out it's not about where you're from, but rather when you're born and how you're integrated into the digital world. So the younger generation and this next generation of engineers is definitely immersed and dependent on technology and IT tools. So as a leader of the industry, it's on us and to make sure that we prepare to welcome them properly with the right tools and with the right environment. So I do tend to push the boundaries with my team and force a certain, let's say, encouragement of trying out new tools. So if you were to take a quick look up my phone, you'll probably see a number of apps that are useless because I keep trying new ones. I try not to do the same to my team, but we do tend to try new tools out there and stay abreast of new changes, let's say.
Oh, that's great. That's exciting. That's exciting, right?
Definitely.
So what do you think, let's see, how do you ensure that your geotechnical solutions are both effective and sustainable as it relates to road and rail infrastructure projects?
I do employ what I believe, and a lot of in the industry are terming it nowadays as 7th dimension geotechnics, right? And many professionals in the sector and many teams, without even knowing it, are working in 4 or 5 dimensions most of the time, and that can seem very abstract, but ultimately, like, the first dimension is like your discrete boreholes, your discrete subsurface characterization, and you go into the second dimension and you're doing your cross-sectional analyses, and you start building your 3-dimensional models, and then you start incorporating time-bound variations already before you know it, you're in the 4th dimension, and you start incorporating cost of putting into effect these solutions that you're devising. All right, then this is most of the work that a lot of the professionals do, and without knowing it, we're actually working in 5 dimensions. So adding the 6, 7, and 8, which are operational constraints and frequencies. Like, say I design a railway with an embankment that has, let's say, lightweight fill with a very specific lightweight lifespan. And if you're forcing your owner at the end of the day to have to replace that material every 10 years, but the actual design is a 70 or 100-year life cycle, then you're incorporating an operational cost or a maintenance cost into your project, into your solution. Same thing with impact of your solution on the environment. So once you get to these 6, 7 dimensions, you're able to capture somewhat wholesomely an effective sustainable design. So always think 7-dimension geotechniques, and you're very close to being certain that your design is effective from the sustainable spectrum.
Fascinating. I've never heard it said that way. Makes perfect sense. I've never heard it said that way.
Oh.
So you said 7 dimensions. I was like, I need to know what this is. And it's what we're doing. I just never heard it coined that way. So thank you for that.
Definitely. And sometimes all it takes, is framing it in a certain way to jolt a certain reaction. And before you know it, and I'm happy that I've created that reaction with you. Then maybe you'll think of this when you're putting together a solution for a project.
Mm-hmm. For sure. Let's discuss the importance of soil improvement techniques in your field.
I knew you were going to go there, but listen, I am from Ottawa, Eastern Ontario in Canada, and then for the vast majority in Quebec, we actually sit on this large deposit of what we love to call the Lida clay, or the Champlain Sea clay. It's a clay deposit. It's a marine clay deposit that often has marginal over consolidation, oftentimes even none. And then you'd be surprised. Then a lot of geotech engineers from different parts of the world get surprised when I say we sit on clay that has virtually no over consolidation. On top of that, it's highly sensitive to remolding. It loses its strength.
Oh my!
If you were to play with it. So, long story short, being a geotech engineer, myself and others in the region, we have the privilege, but also the responsibility of putting together design solutions for major infrastructure projects that require ground improvement. And without it, some of the landmark projects that we've been able to accomplish and put together here in Eastern Canada would not be possible. So ground improvement, that's part of my life. That's actually an integral part of my life.
Yeah, I can't live without it.
Oh, yes.
Oh, my goodness. Let's say as a member of several technical committees, how do you integrate international standards and practice into your projects at Atkins Realis?
So one of the things that we do at Atkins Realis is, I guess intentionally, but to a certain extent, but also naturally, we have an internal organization that mirrors the world, and we're not limited geographically, saying I lead my practice here in this region, and that's what I do, and I don't interact with the rest of the world. To the contrary, we do have global networks of technical professionals that are aligned in disciplines, and I myself sit on a couple of these networks. So whenever there is advancements or new proposed standards and solutions that are put forward in different parts of the world, whether it be it international standards, practices, lessons learned, best approaches, those are discussed and reflected in these global networks at Atkins Realis. And we have the opportunity to leverage different tools that we have internally to let that information permeate to our professionals, whether it be it very regularly held lunch and learn sessions or actual repositories of knowledge base, whether it be it case studies or best practices and pure knowledge of new discoveries. We highly encourage and we actually challenge our seniors and our professionals to share that. And it's something that's made available to our practitioners and our professionals. And as a result, we have access to these standards internationally, and we do get the opportunity to leverage them on our projects.
Fantastic. And before we take our break, final piece of advice you'd like to give engineers that are listening or watching that want to be leaders in the field of geotechnical engineering?
So I told my wife this weekend I'm going to be on the podcast with Jared, and he's probably going to ask something about leadership. And she pointed me to something I always tell her, and I always tell the kids, is like, very simply put, learn as much as you can from every situation. And if someone is telling you, I'm not learning from this situation, you're not looking hard enough. Honestly speaking, because I sit in negotiating tables across clients and competitors, and some of the skills that come in handy is what I learned back when I was a cashier at a grocery store, and learned on how to communicate and how to greet someone and make them crack a joke quickly to grab the attention of the group, but also get the right message across. So take every situation for what it is and learn from it. There's always a lesson to be pulled from every situation.
I love it. I've heard it once said, instead of thinking of win or lose, it's win or learn. Right?
Oh, that's a good one. I've never heard of that one. That's a really good one. I'll use it.
I love it. Feel free to take that one. All right, great. Well, this has been really good. We're going to take a moment to take a break now, and we'll come back in just a minute to close this one out with Gohe and our Career Factor Safety End segment. Stick around. All right, welcome back. It's time for our Career Factor Safety End segment. In geotechnical engineering, just like many disciplines of engineering, it's important to incorporate a factor safety into your design. But what about incorporating a factor safety into your career? Today, of course, we're speaking to Gohe Metaferia from Atkins Realis. So Gohe, you've already had a very successful career. I mean, you're still in your career, But when you look back in your career, what's one thing you've implemented in your career to give yourself, let's call it a factor of safety in your career?
Honestly, looking back, I would say a really good cushion to my career has been the network. And I can't emphasize enough how important it is to stay in touch with technical community outside of work and your colleagues, your clients, your suppliers, former colleagues. And in geotech engineering in particular, we're very lucky that there's so many conferences, seminars, and local chapters of different associations that we can be part of. Whether you're early on in your career, somewhat advanced, or at the end, I bet you everyone would agree with me that being part of those communities is actually a very fulfilling sentiment, and it's something that you can fall back on to pick yourself up and make sure that you always have that factor of safety in your career. So work hard at your network, work hard at building and enriching it.
Excellent. Thank you so much, Gohe. Thank you for coming on and for sharing all these great insights with us. You shared some great information and advice that's going to be helpful for those that are listening and for those that are watching. If somebody wants to reach out to you, where can they find you? Social media or an email you want to share that we can put in the show notes? How can people find you?
Definitely. Somewhat active on LinkedIn, so they can reach out to me there, and I will provide you with my email address later on, and that's something I also monitor very actively.
Okay, excellent. Thank you for coming on. This is a pleasure. It really was.
Same here. A pleasure is mine to be part of a podcast that I've been listening to for a while now.
Excellent. All right. Thank you so much.
Cheers.
I hope you enjoyed the episode today. We would love to hear your feedback, comments, and/or questions. Please feel free to go to geotechnicalengineeringpodcast.com, where you'll find a summary of the key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, I wish you the very best in all of your geotechnical engineering endeavors. Peace.